Hello, today we're going to talk about other methods of solving quadratic equations, starting with square root method. So before we get into that, it's important that you know and recognize your perfect squares and their square roots. So if you need to, take a moment to pause the video and jot these down, because again, this will be important in regards to helping you to simplify radicals as we move forward in solving. So the importance of knowing your perfect squares and their square roots is to make it easier to simplify radicals. Because if you know the largest perfect square that goes into a number, then it can make it easier to simplify it. For example, the square root of 12, with 4 being the largest perfect square that goes into 4, and you know the square root of 4 is 2, then that easily simplifies to 2 square root of 3. However, if you break numbers down into their prime factorization and pull your pairs out, you can also simplify them. So another example we have here is the square root of 40. Again, 4 being that largest perfect square, pull the 2, we're left with the square root of 10. If we do the factorization, we have a pair of 2's, which we pull out, we're left with 2 times 5, which is 10. So either way, we come out with the same answer. So what I would like for you to do now is pause the video, take a moment, and simplify these 3 square roots. So to simplify the square root of 24, the largest perfect square being 4, so I can make this the square root of 4 times 6, or 2 square root of 6. If I did the factorization, 2 times 2 times 2 times 3, there's my pairs. Pull the 2, 2 times 3, I'm left with 6. So pairs can come out, everything else must remain. If I look at 50, I know that's the square root of 25 times 2. The square root of 25 is 5. I'm left with the square root of 2. Or 5 times 5 times 2. There's my pairs. I'm still left with 5 square root of 2. The square root of 48, and this is where it becomes important that it's the largest perfect square. So this is going to be the square root of 16 times 3, or 4 square root of 3. But if I did the factorization of 48, that's 2 times 2 times 2 times 2 times 3. So I got a pair of 2's, pull it out. I got a second pair of 2's, pull it out. I'm left with that 3. 2 times 2 is still 4 square root of 3. So each pair you will pull out individually, or again recognize the largest perfect squares. So this becomes important in regards to the square root method, because if we have a quadratic and we can get that quadratic where we can isolate the square. So we want to get x squared equal to plus or minus c, so that we can take the square root of both sides. And when you take the square root of both sides, you must have the plus or minus in front. Because, for example, 2 squared is equal to 4, but also negative 2 squared is equal to 4. That's why you have to have plus or minus, because it can be either value that squares to get that positive 4. The important thing, again, that you have to do is isolate your square. So if I have x squared minus 36, I need to add 36 to both sides. That gives me x squared equals 36. Square root both sides. I can pull the x, and plus or minus the square root of 36 is 6. So if I have x squared minus 4, again, I'll add 4. So that x squared is equal to 4. Square root both sides. Pull the x, that's equal. Put the plus or minus in front, and the square root of 4 is 2. Even if you have something such as this, where you have a quantity, I have to divide by 2 to get x squared plus 4 equals 5. Subtract 4, x squared equals 1, square root both sides, x is plus or minus 1. So again, the objective is to isolate the square, take the square root of both sides, and solve. So see if you can do number 1, 2, and let's say 4. Pause the video for a moment and see if you can do those 3. All right. This one's easy. We're going to square root both sides. So x is going to be plus or minus 10. And as usual, if you substitute to check your answer, you can determine if you're correct or not. Here, we're going to add 180 to both sides to get 5x squared equals 180. Divide by 5. So now we have our square isolated. So x squared is equal to 36. Take the square root of both sides. So x is equal to plus or minus 6. Again, you must have the plus or minus. Now, 4 is slightly different than what we're accustomed to because it's a quantity square, but our process is not going to change. We're still going to isolate it. So the first thing we're going to do is multiply, get this out of the way, both sides by 3. Because that's the reciprocal of 1/3. So we get x plus 5 squared equals 21. Now that we have the square isolated, I'm still going to take the square root of both sides. But now I'm pulling x plus 5. And that's going to be equal to plus or minus the square root of 21. There's no perfect square that goes into 21. The factorization would be 7 times 3. So we're going to leave that. But we're going to have 2 separate answers still. Because we're still going to subtract the 5. So we'll have negative 5 plus or minus the square root of 21. So if you had to write 2 separate answers, you would have x is equal to negative 5 minus the square root of 21 and negative 5 plus the square root of 21. Both answers. Okay? So let's go through number 6. again, because we're going to isolate that quantity squared, so we're going to subtract 4 and get 3 times x minus 2 squared equals 48. Next, I'm going to divide by 3 to get x minus 2 squared equals 16. So I have isolated my square. Now I'm going to square root both sides. So I have x minus 2 is equal to plus or minus 4. So I still have 2 equations I need to solve. Because so I can look at it 2 ways. I can add 2 and say x is equal to 2 plus or minus 4, which is x is equal to 2 minus 4 and 2 plus 4. So my answers would be -2 and positive 6. No different than if I solved x minus 2 equal -4. I'm still going to add 2. And x minus 2 equals positive 4. I'm still going to add 2 and get the following answers. So isolate square, square root, both sides, and solve accordingly. Alright, so now let's talk about our quadratic formula, which is another way, foolproof way. We can solve our quadratic formula regardless of if it can be factored. Traditionally, we typically use it when it cannot be factored. But even if it can, you can still use a quadratic formula. It just takes a long time. So, to realize, in order to use a quadratic formula, your equation has to be in standard form. So it's got to be in ax squared plus bx plus c equal to 0. Okay, because you have to be able to identify a, b, and c. And then you can plug and chug and solve. So if we look at this example, a is 1, because that's what's understood to be here next to the square. There's no number physically there. B is -2, and B is +2, and C is -8. So we're just going to plug and chug. X is going to be equal to the opposite of 2, or -2, plus or minus the square root of 2 squared minus 4 times 1 times -8. All over 2 times 1. So as we continue to simplify, -2 plus or minus the square root of 4 plus 32 over 2. So -2 plus or minus the square root of 36 over 2. So this is where simplifying the radical comes into play. So that's going to be -2 plus or minus 6 over 2. So again, when you're writing your answers, x is going to be equal to, well, let me back up 1 second and we notice something. We have 2, 2, and 6, and so we can divide into all of those. So we can rewrite this to make it a little bit easier for ourselves, as x is equal to -1 plus or minus 3. which we still have to split, is -1 minus 3 and -1 plus 3. So our answer would be x is equal to -4 and 2. Which, if you factor it, you would get the same thing. Now on this example, notice the equation is not set equal to 0. So we're going to set it equal to 0 by adding 8. So our equation will become x squared minus 8x plus 8 equals 0. Now we can use the quadratic formula. So we can identify A, again, is 1, B is -8, and C as +8. So we're just going to plug and chug again. X is going to be equal to the opposite of -8 plus or minus the square root of -8 squared minus 4 times 1 times 8 all over 2 times 1. So the opposite of -8 is going to be +8 plus or minus the square root of 64 minus 32 all over 2, which becomes 8 plus or minus the square root of 32 over 2. So we have to, again, simplify that square root of 32, which becomes x equals 8 plus or minus 4 square root of 2 all over 2. So again, we're looking at 4, 8, and 2. A number that goes into all three is 2. So my final answer here is x is equal to 4 plus or minus the square root 2 square root of 2. So there are your two answers. If you had to split them, x is equal to 4 minus 2 square root of 2 and 4 plus 2 square root of 2. All right, pause the video and see if you can do the next example on your own. All right, hopefully we noticed that we had to add 6 to both sides in order to first get our equation equal to 0. So here we have A is equal to 1, B is -4, and C is +6. So again, plug and chug. The opposite of -4 is going to be +4 plus or minus the square root -4 squared minus 4 times 1 times 6 all over 2 times 1. So 4 plus or minus the square root of 16 minus 24 over 2. So we end up with 4 plus or minus the square root of -8 over 2. So here's something you haven't seen before. Anytime you have a negative under the radical, you are going to pull your I out. Not your I for your vision, lowercase I. So this, because the square root of -1 is equal to I. And that's what we used anytime that there's a negative under the radical. So this becomes 4 plus or minus I square root of 8 over 2. And now I will simplify the square root of 8 as I typically would, making sure that I is in front of the radical. So this becomes 4 plus or minus 2I square root of 2 all over 2. Again, we have 2, 2, and 4. So our final answer is going to be x is equal to 2 plus or minus I square root of 2. And if we got to split it, x is equal to 2 minus I square root of 2 and 2 plus I square root of 2. So anytime the negative's under the radical, you're pulling your I out. So if we had something that was perfect, like if we had the square root of 9, we know that's equal to 3. So the square root of negative 9 is 3i. So I will go in front of radicals but behind integers. So if it was the square root of negative 5, that can't be simplified, so it's just I square root of 5. In front of radicals, behind integers. In front of radicals, behind integers. Right. Pause the video and see if you can do this one on your own. So here we have A is now 2, B is negative 8, and C is negative 3. So x is going to be equal to positive 8 plus or minus, if we square negative 8, we're going to get 64 minus 4 times 2 times negative 3. All over 2 times 2. So we get to 8 plus or minus the square root of 64 plus 4 times 2 is 8, 3 is 24, so plus 24 over 4. 8 plus or minus the square root of 88 over 4. So again, we got to simplify that square root of 88. So x is equal to 8 plus or minus 4 or 2 square root of 22. It's a lot of 2's over 4. So again, recognize 4, 2, and 8. We know 2 goes into all of those, so x is going to be equal to 4 plus or minus the square root of 22. Notice I have not changed anything under the radical, over 2. So if you had to split it, you could write it as x is equal to 2 minus the square root of 22 over 2 and 2 plus the square root of 22 over 2. Now let's talk about our discriminant. B squared minus 4ac, which notice is a part of our quadratic formula. So here, notice A is 1, B is 5, and C is 6. So take a moment and use Desmos or your calculator to put this equation into your calculator so you can see the graph. But also if we do B squared minus 4ac, we will get 5 squared minus 4 times 1 times 6. So we get 25 minus 24, we get 1. So if we look at our graph, we want to notice it crosses the x-axis twice, which means we have 2 solutions as we've touched on before. Notice what those solutions are. because also if you were to factor it, those are all zeros. Remember zeros, solutions, x-intercepts, roots, all of those essentially are the same. So anytime your discriminant is greater than 0, anytime it is greater than 0, you have two real solutions, which means it crosses the x-axis twice. Two real solutions. All right. So now put the x squared plus 6x plus 9 into your calculator and graph it. Also recognize that a is 1, b is 6, c is 9. So now we're going to go 6 squared minus 4 times 1 times 9. So now 36 minus 36, we get 0. So when you look at the graph, it hits the x-axis and bounces. So there is one real solution. And that's referred to as a double root. That's from the perfect trinomial. Okay? Double is twice, so you still have two solutions technically, but it's one real solution. So anytime your discriminant is equal to 0, you have one real solution. So if you have the b squared minus 4ac again here, graph that equation. Put that in Desmos or your calculator. Notice now a is 2, b is -5, and c is 4. So if we go -5 squared minus 4 times 2 times 4, 25 minus 32, we get -7. So when you look at the graph, it does not touch the x-axis. So that means we're going to also have a negative under our radical when we do our square root, when we solve our quadratic formula. So that means we have two imaginary solutions because you would pull an I out. So anytime your graph does not touch the x-axis, you have two imaginary solutions so that your discriminant is less than 0. Again, two imaginary solutions. Because given that I have already done the quadratic formula, well, if I use the quadratic formula, I've done the discriminant part. So this would be x is equal to 5 plus or minus the square root of -7 over 4. Because a is 2. 2 times 2 is 4. So your answer, you would have to pull the I out. 5 plus or minus I square root of 7 over 4. And if you had to split your answer, 5 minus I square root of 7 over 4, and 5 plus I square root of 7 over 4. So anytime you have the imaginary number in your solution, you have your two imaginary solutions. They always come in pairs, never just one. So your quadratic formula is what you can always use to solve your quadratics. Remember that your discriminant, which is a part of your quadratic formula, if that is greater than 0, two real solutions. If that is equal to 0, one real solution. And if it's less than 0, it's two imaginary. All right, continue to practice independently, and please let me know if you have questions.